Everybody see those slides?
We can see them.
Excellent.
Introduction.
I just hear a few more beeps, so I was waiting until those settle down. Well, welcome everyone to the 2026 WSGC Collegiate Rocket Competition. So this is a brief agenda, so we'll take a look at the dozen teams for this year, just reminding you of the eligibility of team members, look at the funding, the prizes, the challenge, details, deliverables that we ask for during your flight, how we define a safe and successful flight, how the scoring runs, highlight some of the main components of the challenge and the documentation, quick look at the calendar of events, highlight some of the deadlines, remind you of the Launch to Learn coming up, and the team demo flight of a small rocket, which should happen soon. You'd like to do it before the snow flies, and then any questions and answers at the end, we'll take those.
Hey, Glenn, can you put that in presentation mode?
Yes, I can. Let's see. Slideshow. Is that better?
Beautiful. Thank you.
I admitted Dr. Sunarine from UWRF. All right, so we have a dozen teams, which is excellent. Alverno College, Carroll University, Carthage College, Lawrence University, Marquette, UW Green Bay, UWGV Sheboygan, UW La Crosse, Platteville, River Falls, Stevens Point, and Whitewater. That's a great group. More than we've had in a while. So the competition funding, I think this says $750, but I believe we're making $1,000 available per team for a dozen teams. I believe we budgeted for that. So I will correct that in the slides that are sent around. On launch day, each team will get one motor casing load for one launch. If you'd like to launch again, you're welcome to do that if you want to pay for another motor. Ejection charges will be provided, so we do not want teams bringing their own gunpowder and loading them there, just for safety reasons. Competition data recorder altimeter will be supplied for the official altitude and acceleration velocity details that come as part of that altimeter package. Teams are welcome to pursue additional funding from their own school. Any sponsors you have, that's fine if you want to add to your funds available. The travel reimbursement depends on how far away your school is from the launch site. If you're within 50 miles, hopefully you can drive there and back without needing a lodging. Between 50 and 100 miles, teams get one night in hotel, up to 2 rooms. And if you're from more than 100 miles away, then you get 2 hotel nights, up to 2 rooms for your team members. The first place prize, grand champion, gets $3,000 for the team to use as you wish, plus a VIP tour at Sierra Space. That's for the highest scoring team overall, successfully completing the mission and all aspects of the competition. So the total scores of the reports, the reviews, presentations, the launch day, all of those things. Second place team gets $2,000 and the third place team gets $1,000. So as you've seen, this is the general 2026 flight profile example. So you must have a way to stabilize the rocket and ensure that the mechanism is unable to be activated, does not activate until after the motor burnout. And you need to show stability for 5 seconds after motor burnout to hopefully have no roll or tilt. So we'd like it to be vertical and not spinning for 5 seconds after motor burnout. And then You will control a 90-degree roll in one direction or the other about the main axis, and then roll it back 90 degrees in the other direction and re-stabilize it for no roll and verticality before it reaches apogee, at which point the drill will deploy. Ideally at 3,800 feet, so that's the target, but we are plus or minus 400 feet on that, so 3,400 minimum. So your rocket needs to at least get to 3,400 no matter what, and not get any more beyond 4,200 feet. So we like it within that range. The closer to 3,800 feet, the better. But also the closer to your prediction. If for some reason you think we're only going to make 3,401 feet, then if you predict that and that's exactly what you get, then that is a good score. But since you didn't reach 3,800, it's not quite as good as scoring, but as the fact that you nailed your prediction, even though it wasn't 3,800 feet, is worthwhile. So you want to try to do that accurately and get that as close to 3,800 as you can. And then your rocket will descend under the drogue chute until at least 300 feet above the ground. It will deploy the main chute and have a electronic downed rocket recovery signal of some sort, like a GPS, so that you will be able to find your rocket easily. And I just switched my screen to try to get rid of the chat on the right so I could see everything on the slide. And you have an approved motor list. So at some point in the calendar schedule, we will ask you to declare precisely which of these motors you will use. So you're limited to a selection from one of those available. All 38 millimeter diameter motors, say 435, 425, or 350. So here are the competition deliverables. One is a stable flight after the motor burnout, vertical no rotation as mentioned, an autonomous active roll control system, clockwise one way. Well, here it says clockwise 90 followed by counterclockwise around the main axis. So just to give you a preference, ideally, top scores will do it precisely that way, clockwise 90 and 90 counterclockwise. And you should have an ability to continuously measure the speed, altitude, acceleration throughout the flight via avionics that is separate from an off-the-shelf altimeter. So your own electronics in order to measure all of those things. One way to record the downward-looking flight video via an onboard camera. However you decide to do that. Inside looking out, attached to the outside, via mirrors, lenses, whatever you like. Just need a downward-looking flight video to confirm and verify the rotation one way and the other way based on the view of the ground, and complete a safe and successful flight. The details of that will be defined shortly. Have a dual deploy recovery system. So the motor ejection is a backup, and you should rely on your own electronic deployment charges at apogee and on the way down several hundred feet above the ground. So those are a dual deploy system. So your altimeter will have two separate altitudes set for those deployments of the charges. So the motor is only a backup, not the main recovery deployment mechanism. And your electronic down rocket location aid needs to be something like GPS or RF with an antenna where you can track it and get you in the right direction to find your down rocket. So just an audible alone or a colored smoke is not enough. So generally, if it gets out of sight and over the trees or those just things you just can't hear from a great distance or necessarily see from a great distance. So you want to make sure you have some electronic ability to seek out and find your rocket no matter where it ends up. So as mentioned, the nearest the max altitude, max speed, target altitude, and 90-degree rotations are best for top scoring. Optimal scores will be for exactly 3,800 feet altitude, precisely 90 degrees rotation, supported by your onboard data acquisition and video with a safe landing. And you want to ensure that you have at least a 5-to-1 thrust to weight ratio off the launch pad tower. So in your simulations, you want to make sure you have a tower of the correct height of the tower. So they're not always the same. So check that, what towers will be available on launch day so that you know the speed at which your rocket will exit the launch tower.
Glenn, before you move, I know there was a question in the chat.
Okay.
With the spin, we're saying clockwise 90 degrees, followed by the counterclockwise. It was sort of, is that viewed from below? Is that viewed from above? Are we minding internally? I don't know if we specified specifically as
We
viewed
didn't
from
actually.
above,
I
going from
I
the
noticed that
ground.
as I read it that it doesn't say viewed from above or below. I will say from above, since that is oftentimes how we view things as I'm drawing it out. So from the camera's eye, you want the rocket to go clockwise direction, which means the ground is going the other way. As viewed from the eye of the camera looking down. Good
Yeah,
question.
most of the pertinent information we're going to look for through the camera.
Yeah.
And if your camera fails, we can look at your SRAD electronics that you've devised to record the action of the rocket on its rotation or on its true stable trajectory.
Yes, if your altimeter components, the electronics that you have to measure the accelerations, if they can verify the axial rotations properly, if your camera fails for some reason, then that will be sufficient to verify your rotations. But it won't score top score, but it will score well. So we just want to highlight that the camera is part of optimal scoring, having that view as well.
So buy a decent camera that works properly. Most rocket cameras, they're not real expensive, and they're pretty reliable. So make sure it works on the event on launch day.
So thanks for keeping an eye on those chats, Rob. If anything else comes up, just let me know. So for a safe and successful flight, for a safe flight, you must launch, be stable, nearly vertical. We understand that depends a lot on the wind and conditions at the time, but nearly vertical flight during ascent. Nothing going sideways in any way. Recovery systems must deploy successfully the drogue and the main parachutes, and your rocket must be recovered in ready to fly condition, which means pretty much you bring it back, you reset, repack the chutes, you put in a new motor, and it's ready to go. If it's a little scuffed up, no worries, but the fins must be firmly, still stably attached. No pieces broken off. The nose cone must still be a nose cone and not embedded in the ground. All of that able to be recovered. You don't have to relaunch. It just needs to be able to be launched again shortly if you wanted to. For a successful flight, first it needs to be safe, and then you want your apogee within the window of 3,400 to 4,200 feet. Some degree of active roll control during the coast phase. We realize it may be difficult to get exactly 90 degrees this way and that way in precisely the clockwise, counterclockwise sequence. But if there's a demonstration of some degree of roll control, activation of your fins, so, or whatever mechanism you're using to control the roll, if that's visible on camera, that it's trying to do what you want it to do, then that's very good. Some measurement of accelerations during the flight with your onboard electronics, linear and rotational ideally, and acquisition of downward looking video.
Yeah, the reason why we're doing this rotation 90 degrees, it's kind of a check, making sure your autonomous mechanisms are working properly. Because we just want you to show up at the launch with a perfectly aligned true profile rocket that would fly straight as an arrow. So that's why we want you to have that check on the rotation. That's why we're doing that.
And the mechanism to do the rotation, the angle of attack of those must be limited. So not too many degrees from vertical so that you can't steer it completely sideways or upside down. So we want to avoid that possibility. So hard stops on those things, whether it's internal or external via the mechanical structure, you definitely want to limit how far any of those mechanisms can steer the rocket. We will not be building any guided missiles. The components of scoring, the weighting is 10% for each of the reports. So your preliminary design review, your critical design review, and your flight readiness review, those are all 10%. Your flight readiness review presentation is 10%. The oral one at Carthage the night before launch. The competition flight in person at Bong Recreation Area is 30% of the overall score. Your post-launch analysis review is another 10% written report. And your project management throughout, so starting tonight and going through the end, attendance, submitting forms, meetings such as this, uploads of RockSim and the other things, your virtual reviews, when we do the safety review of your rocket, looking them over, those types of things, making sure everything is set and meeting those deadlines. So that's an overall 10% of your score. And then the education outreach is the final 10% to make the overall 100%. Any submissions received after 11:59 Central, well, now it's, standard time. So we've just gotten rid of daylight savings time, but when it comes back in March, then that's in place. So whatever the clock is in Wisconsin at 11:59, depending on the calendar, that is the deadline before it turns to the next day. So things after that will be considered late, will certainly be accepted, but the points that you receive for that will be reduced 20% each day they are late. So it's really helpful to get things in on time. Just to get you used to real world things, when the government says the deadline for your grant is this day, this time, it is that day and that time, and there's no other way around it. So there is no late penalty for government grants. It's just not even going to be considered if it's late. So just good to get used to those types of things, that those are harsh deadlines.
Please, no procrastinating.
So I won't go through all these details, but just in general, your preliminary design review. So this is only a highlight of some of the things you want to make sure that you have in your preliminary design review report. And so main thing are design goals. So in order to score your best on all these reports, the closer attention you pay to these things that are being requested, the better. So how is the rocket and payload performance measured by the competition? What do you plan to design first? Is it your rocket? Is it your payload? Do you work on them all together? What does the team define as the most important thing for your design? Various constraints of the competition, which you're also limited by the motor, so that will affect your weight and your design and your number of fins, all those things. Any limits your team has chosen to include. On top of those, your budget is limited. The people are limited. The skills you have is limited. So you can't have an outlandish idea that nobody is able to accomplish, even though it may work in the real world on a satellite or a rocket. You have to make sure that you can do that amongst yourselves with the equipment and funding and skills you have available. And then describe your at least preliminary solution to the challenge. In this case, how are you going to get the rocket to rotate? This doesn't have to be your final design. You're going to learn things as you go. You're definitely going to tweak things as you go. Some things you think will work won't work as well as you thought, or you may find something to work better. So this preliminary design review is just to show that you've thought about those things and decided on a way to tackle those things, but not necessarily your final answer. Your design can change as you go along. But you want it to be mocked up in a RockSim model of your preliminary design plan and solution, and show that at least on paper on the simulation it does the minimal things that it's required to do. It reaches 3,400 feet with the motor and the essential components of the rocket that need to be included. So your weight, you want to have a reasonable weight, which is best to weigh the things that you have, and don't trust what it may say online that this component weighs this many grams. Once you put it on your rocket and you add some epoxy and other things, it's best to check the weights of everything that you add and your overall rocket weight many times to make sure you're staying in range of what you need. The critical design review is more advanced, a later stage. So you've gone through some more testing and evaluation of the various aspects of the rocket. And so the design features of your payload, background information on various methods for active control and how you're going to monitor these things, describing those methods, describing your avionics system design, what camera are you going to use, have you tested that out, your various recovery systems for the altimeter you're going to use on your own, so not the one provided by WSGC in order to get the altitude, but your own system, which will be set to deploy the charges at given apogee and altitude. Parachute you're using, the shock cord, how are they tied up? How is everything affixed to the bulkheads in the rocket? Those types of things. Analyze your anticipated performance. What is your thrust to weight ratio? So have you calculated that? Is it at least the 5-to-1 that's requested? Estimate your velocity off the launch rail, let's say at 10 feet altitude if you have a long rail. Estimate the maximum altitude of the rocket, the peak acceleration, and your acceleration versus time, altitude versus time. So essentially the profile that RockSim will give you when you install the motor and set it to launch. RockSim will tell you all these things, give you a profile of the launch at a given chosen wind speed. So you may want to do a range of those things, see how it changes with the weather conditions. Your flight readiness report is really the final design, showing everything is ready to go. So include details about any testing you've done of the video, of the electronics, avionics system. And so various things that are good to know. What is the volume of your parachute deployment chamber? That's important to know for how many grams of black powder you're going to use in order to eject your chute. And you need to know the area of the air holes that are in your chamber that will reduce that pressure somewhat based on the maximum pressure provided by the powder. So you want to make sure that it is sufficient to eject your chute, which will make sure you have the right number of shear pins and the size of shear pins that at that pressure will actually shear and release your chute. For a sufficient amount of black powder, you will have a certain grammage of black powder pre-packaged available at the launch site. So that is not unlimited. If you want 12 grams, we're not giving you 12 grams of black powder. So Frank will tell you the most grams that he will give you packed in a tube. And so you want to make sure that you're within that range for the volume of your chamber, for the chute, and for the shear pins that you have. And then there's those are the things that you were asked for before in the earlier report, but just reiterating those things. Verifying again that you have your final design does have the proper thrust to weight ratio, rail guide velocity, max altitude, all those things within the requested range. Your educational outreach is where your team shares information pertinent to aerospace with a group. So this is really wide open. So it's up to you, depending on the contacts you have, the institutions or schools or other clubs available in your area that may be interested in an outreach presentation of some sort. So you can meet with a K-12 class, student organization, a scout group that is, involved in rocketry. So presentation to a community or a group on campus, describe the competition and your team's design, and also discussing some of the opportunities at NASA or through WSGC available to students. So there are lots of things available, opportunities available that other than high-powered rocketry available at WSGC. So it's good to let people know about all those opportunities. And the representative at the event will fill out and return your education public outreach form that you'll submit to WSGC for those 10% of your overall points. You're welcome to do that anytime, so you don't have to wait until near the deadline for that presentation. So if you get that organized early and you have a presentation and about rocketry and WSGC opportunities available earlier, then you can certainly do that earlier rather than later. So that's really up to you when you work that out with the group who's willing to sponsor or have you there for a presentation. Then set that up and get that done as soon as you like. Your flight readiness presentation oral at WSGC at Carthage the night before launch will be delivered by the team in front of judges and an audience of other teams and anybody else who shows up. And all members who deliver any part of the presentation or who will respond to judges' questions must be in the podium area when the presentation starts and introduced to the judges. So you're welcome to do that as a tag team up in front of the judges or have one person as your designated presenter. That's really however you like to do that. Only members who are part of this presentation group will be able to answer the judges' questions. Overall, you'll have 7 minutes. And the presentation itself will proceed until you're done, and then questions will follow after that. And we'd like only judges to ask questions, especially with 12 teams. We don't want to keep everybody all night since you must go back to your hotels or homes if you're close and prepare for launch early the next morning. So we'll try not to keep you too late. In your post-flight assessment, will essentially do just that, assess how your rocket met all the design goals that you had hoped for. And all the way from pre-launch to launch, the ascent, the deployment of chutes, the descent of the rocket, the recovery of the rocket, how well the payload performed, So show the plots of your altitude and acceleration versus time. Compare those to what the predictions were with RockSim, the maximums that you had decided. See how well you've met those. And this is okay. This is actually wrong here as far as mentioning the high pressure avionics. And so that was last year's goal, was to measure the pressure inside the chamber. And so you don't need high pressure avionics necessarily, but your implemented stabilization system and the performance for the rotation 90 degrees one way or the other is key. So that is the second point there. The actual versus predicted performance. You look at the acceleration and velocity, altitudes, how close your rotation got to 90 degrees one way and 90 degrees the other way, how stable it was before and after the rotations. Have photographic documentation of the flight and team members. Essentially, when you find the rocket, hopefully safely in the field with the chute deployed and it happily resting in the field intact with the team members beside it as you find it. It's good to take a picture of that. And so the project management that was mentioned to be 10% of your overall score, these are the main things that are part of that, which are essentially 10 key things which are highlighted in these points. Your preliminary design report, your critical design review, your flight readiness report, your educational outreach, your upload of your presentation, which is days before your actual presentation. So we want to have those in hand well before actual presentations start, just so that we're sure everybody has their slides prepared and organized and ready to go. So you cannot bring those at the time 5 minutes before walking up to do your presentation. So we'd like to have those uploaded by the deadline in the days leading up to that presentation day. So make sure you look at that in the calendar. And overall effective team communications, timeliness, professionalism, your attendance at mandatory meetings. The preliminary design review will have a virtual tag up after those are submitted in case we see anything in that preliminary design review that we think, oh, you really need to address this. We don't see it in your PDR. And so we will have a virtual tag up with all teams to say, yep, that looks good. Keep going. Or what about this? What about that? So we can make suggestions if there are any. If there's anything that just looks like it's lacking that you haven't put in that PDR that maybe you just hadn't thought of for some reason, then we'll remind you of that. Or if we see something that looks dangerous or needs to be addressed, then we'll point that out. So things you can tweak after your PDR, the competition update, and the virtual review after critical design report. So those key things, your virtual safety and design reviews, and the final inspection, which occurs on the night of your presentation. So judges will look over your rocket at the presentation and see that it looks reasonable. We need to see things like, yes, you have a place to mount the altimeter, which will be provided. And it looks like, yes, your fins are stable, your nose cone is stable, your center of gravity and center of pressure are marked and look reasonable for stability of the rocket, those types of things. The Launch to Learn is coming up, so only a couple weeks away. A lot of people are signed up for that. So that is not a required workshop, but for those who want to build a rocket from a kit, which will be ready to fly and certify at level 1, if you choose to fly it and get certified, Could be on launch day itself after your main rocket launches, or it could be another day where launches are available. In general, up to 2 participants per team, but there can be more per team. If you've purchased extra kits, then that's fine. If other people are watching, that's also fine. But if you're going to certify, you need to be the one to build that rocket completely, start to finish. The person who's getting certified for the flight of that rocket needs to be the one who builds that rocket. The kits are almost on their way, if they're not already on their way to every location for those who are signed up to do the Launch to Learn. So hopefully you will get those within the coming days, because the idea is on Thursday for us to have a kit reveal where we will set up a Zoom like this, and everybody who has a kit will open it up on camera and we'll see that yes, you have all the supplies within that kit. If something was forgot, then we will have some time to remedy that and get you those components quickly. Just to check, you never know when something just doesn't end up in the box for your kit. So we just want to check to see that we don't get surprised on Saturday morning when we're building the rocket on the Launch to Learn that, oh, you don't have fins or you don't have a nose cone or those kind of things. So we want to find that out early so we can take care of that if needed. The demonstration flight, which is required in the calendar before too long, is a small model rocket that does not need any air traffic clearance, so you don't need to come to any Bong recreation area to launch your little rocket. So you can do it in the backyard as long as you don't have too many trees around and you can recover it. So anywhere you like, purchase a low power model rocket flight kit, assemble it, fly it, recover it, take a picture to document it before and after flight. And video would be nice with team members in the frame of the little rocket going up and coming down. It doesn't have to reach any particular altitude. It needs to go up and it needs to come down, and that's about it. So post those videos to WSGC Facebook page or elsewhere if there are other options for posting that with the flight date and location, and upload that link to the grant management page, which your team lead and perhaps one other person will have ability to upload things to your accounts on the WSGC page at Carthage. These are only some examples of rocket kits, but again, there are lots and lots of rocket kits available at SDs or Quest Aerospace or Apogee Rockets or Discount Rocketry, assuming all those are still in business. You're welcome to get a rocket kit from anywhere. So these are just small A, B, C engines, so whatever you like, little solid rocket boosters. So you don't need to be ambitious with this, but you're welcome to be, but you want to be able to recover it and launch it safely. Does anybody have any questions or comments? Some of these questions were from the earlier Q&A session we had when we had the introductory session. So we did mention that WSGC will supply one motor. You can order additional motors if you want to fly more than once. You're welcome to do that if you feel like you can tweak something a little bit and get the altitude that you want. If for some reason you didn't get it, or if it was unstable for some reason, if you need to tweak the algorithm or whatever you need, right? For the rotation autonomous, you can tweak those things, tweak those settings and relaunch if you like. The main tube is 4-inch diameter, but if you have reason to transition to a narrower or a wider tube at some point, you're welcome to do that. We want the minimum altitude for the main deployment of your chute at least 300 feet above the ground on your way down. Your
Yeah,
chute
that would be
needs time to open.
the minimum would be 300 feet.
Yes. It is better to do it a little higher. Of course, if it's too high, right, then it drifts a long way if there's a lot of wind. So you can adjust that depending on the wind conditions. But definitely need time for your main chute to deploy and open and slow your rocket down before it hits. And as mentioned, others can observe the Launch to Learn workshop, but you cannot be assisted in the construction if you're going to get certified on that rocket.
Does everybody have a mentor or looking for a mentor or need a mentor? Everybody must have one, huh?
Everybody's got a high power rocketry mentor.
Yep.
Excellent. I
Yeah.
see head shaking yes.
Yeah, Carthage
Yeah.
has one.
All right, good. I
So
just want to
feel
make
free to
sure.
reach out to them. If you have a question about something, reach out to somebody and ask. If they can't
Right,
answer, they will find somebody who can.
Right, they're waiting for you, or otherwise they might be contacting you. And if you have any issues with a mentor, please contact Wisconsin Space Grant, and we may address a different one or talk to the one you were dealing with if he hasn't been communicating with you. And the odds are, if they haven't been communicating with you, you haven't been communicating with them. So please contact them. And if you don't have a contact address from them, we'll get one for you.
I know there was a question in the chat from Green Bay. What's the expected time for Launch to Learn? If I remember correctly, we were starting at 10 on Saturday. Correct? I'll get a schedule sent out to everyone. We're just adjusting a little bit due to a change in the kit that should shorten the build time just a little bit.
Yeah, I believe we're going to, I think it's still right. We're going to avoid the Friday evening session and just start Saturday morning. Is that right?
Yep. We're going to use the lock-in fin system, so you don't have to epoxy anything inside the tube on the fins.
So
it's
Frank
gonna
is
be
showing
all-
you that right now.
It's all
If you
going to be
can-
glued on the outside like this on the fin can. And all it's going to do is be glued inside the airframe.
So glue the fins on the motor tube first and then slide it up into the frame.
We'll definitely cut down on build time.
That's one of the things I hope is in with the kit, because this is a new change. And I talked a lot about the change on it, and I hope all your parts are in the bag. If not, please let us know as soon as possible. They're assembling them today and probably shipping them out tomorrow. And hopefully they said you'll get them on the 5th, most of you, and some may be delivered on the 6th. So make sure to look at where it's going to be mailed at, your doorstep or wherever that
As
you
soon as you
received the
get it,
rocket.
and you're welcome to open up the box as soon as you get it, go through the equipment list, sort it out, and then you'll be ready to go when we have the kit reveal. Quick chat just to see if it looks like everything is there.
Does anybody have any questions about the competition?
Is everybody aware of how they're going to spin their rocket? I see Platteville saying yes. You don't have to tell us. I'm just curious.
Yeah, Platteville, you're kind of quiet today.
We have some ideas. That's good. You must have ideas. More ideas is better. Test them out. Decide which one you want to go with.
Is Lawrence
Mock-ups.
on here?
Is who?
Is Lawrence on here?
Anybody from Lawrence?
Oh, yeah, UWL.
Lawrence
Oh,
here.
that's lacrosse.
Yep.
That's lacrosse. Okay. I have a Dave Juckham that's gonna contact your lead person there for mentoring, just to let you know.
And while we're checking, by any chance, was there anyone here from Marquette this evening? And then while we have that, Frank, a question just came in the chat. How does the new competition altimeter get attached?
That's in the design process right now. It's either gonna be hooked onto the bulk plate on your eye bolt or your U bolt. It's gonna be inside of a PVC container that's only gonna be like 1 inch. It only weighs altogether it's only gonna weigh probably 4 ounces at the most. Or we're gonna have a 3D printed sled attached to the outside of the rocket.
Yeah, the main thing is wherever it's going to be, you need to be able to access that in your rocket right before launch. So just as your rocket is overlooked for safety and stability construction before your motor goes in and before you take it to the launch pad. So your rocket can't, if it's an internal thing, then your rocket can't be completely sealed up because we need to be able to put that competition altimeter in there. So if it's exterior, then just need to be able to pop it into that 3D printed receptacle on the outside, if that's the way it is. So we'll decide on that and let
yeah,
everybody know.
right, we'll let you know.
Anybody else? Any questions whatsoever?
If not, I do want to just remind everyone, award letters should be out, and don't forget they are due on the 10th. But I know that they're probably getting routed for signatures and all that. So if you run into any issues, please reach out, let us know sooner rather than, when you're rushing at the end.
Yes, well, I would say please don't wait until the last minute to do those things because you may need it signed by your university grants person. So allow adequate time to get all those signatures. $49.96. It's a secret code.
Mhm.
Right.
If anybody has any questions, email me. I will find a person to get the answer if I don't know the answer. Don't be shy about that at all. If you're not sure about anything, is this legal? Can we do this? Can we do that? When do I need this? If it's not in the calendar already, then let us know. But get started. Start doing simulations if you haven't. Start testing out ideas if you haven't. You don't need a full rocket to test things out on. You can test things on a little rocket. You could use your little flight rocket to test some ideas. You can test it out the window. You can test in many ways without actually launching a high-powered rocket.
Rob, has the RockSim license been moving forward?
We should be able to get those out. I'm hoping by the end of the week.
Okay, if anybody has any issues with RockSim, let me know. try to avoid using Open Rocket. I know you like it because it's free, Platteville. I can tell when you import Open Rocket to Roxim, sometimes it doesn't come out right or correct. The flight is pretty close. I'd rather you use Roxim. Roxim's a pretty good program. You get reimbursed for it, so it's no big deal. And it has a lot of good features in it too. It even has calculations of how many grams of black powder to use in a rocket. It's pretty handy. I know there's all kinds of formulas out there, but I always tell you to add another 5/10.
Mhm. It doesn't hurt to use Open Rocket just to check and see. If it's
Right.
giving you a similar answer, if it's giving you something higher, lower, at least gives you a plus or minus, perhaps uncertainty on your prediction. So it gives you a range.
And of course, was it mentioned that they will be downloading a Roxim for us to look at?
Yes,
Okay,
multiple times.
great.
And then don't forget that you guys should be able to get a discounted copy of Roxim, a license for the year as well, just using the award number from the competition in the Apogee website.
Anybody think of anything else as we're reviewing these things? Any other questions come up? I'm scrolling through chats to make sure I didn't miss any. We confirmed clockwise from above. Analog clockwise. In case that's not obvious, I realize these days it may not be.
Well, looks like everybody has their program down and ready to fly,
Excellent. Let's go this weekend.
right? Here we go.
There it is. Nice. That's impressive, Frank.
That's just Zoom.
Everybody good for now? I see some nods. Excellent.
All right.
Thumbs up.
Don't be afraid to ask questions to your mentor and Wisconsin Space Grant. We're here to support you and make sure you succeed in this competition.
That's why we're here. Good luck, everyone. Keep up the good work.
Yep.
Let us know how it's
Thank-
going.
Thank you all. Have a great evening.
You too. See you.